There's a star out there that shouldn't exist. Older than our galaxy. Older, possibly, than the universe itself. Astronomers call it HD 140283. But among scientists, it's earned a far more poetic name, the Methuselah Star. A celestial rebel that breaks the laws of time and challenges everything we thought we knew about the universe's beginning. In 1912, using one of the earliest spectroscopic tools, astronomers first noticed this faint, ancient-looking star shining in the constellation Libra. It wasn't particularly bright, but its light carried a strange fingerprint. Every star is like a cosmic barcode. Its spectrum tells us what it's made of, how fast it's moving, and even how old it might be. And when scientists analyzed this one, something didn't add up. Methuselah Star had very few heavy elements, almost none of the metals younger stars have. In astronomy, that's a red flag for extreme age, because heavy elements are born inside stars and scattered through supernovae. So, the fewer metals a star has, the earlier it must have formed in cosmic history. They ran the calculations, and the numbers stunned them. An estimated age of 14.5 billion years. But there was a problem. The universe itself, according to the most precise cosmological data, is only about 13.8 billion years old. That means this star seemed to be older than time. Scientists double-checked. They recalculated distances, revised the models, reanalyzed the parallax from Hubble data. And even with improved precision, the Methuselah Star still hovered at around 14.27 billion years, give or take. A bit lower, but still brushing against the age of the cosmos itself. How could a star exist before the universe existed? Was the data wrong, or was our entire understanding of cosmic history incomplete? To solve this cosmic paradox, scientists dug deeper. They studied the Methuselah Star's chemical signature, its metallicity, its oxygen content, and the ratio of iron to hydrogen. What they found was fascinating. Methuselah Star is made almost entirely of hydrogen and helium, the raw ingredients of the early universe, with trace amounts of heavier elements like oxygen and iron. This told scientists that the star likely formed shortly after the Big Bang, from material that hadn't yet been enriched by previous generations of stars. But that alone didn't explain the age paradox. The answer lay hidden in the models of stellar evolution. Stars can appear older or younger depending on assumptions about things like helium diffusion, energy transport, and even nuclear reaction rates. And small changes in these models can shift a star's calculated age by hundreds of millions of years. When all uncertainties were combined, scientists concluded Methuselah Star is one of the oldest known stars, likely between 13.0 and 13.2 billion years old. Still ancient. Still nearly as old as the universe, but no longer impossible. Even though it may not predate the universe, Methuselah Star remains a cosmic relic, a living fossil of the early cosmos. It carries within its atoms the memory of the universe's youth, a time when there were no galaxies yet, no planets, no heavy elements, only a fog of hydrogen and helium just beginning to ignite the first lights of creation. Studying it helps astronomers understand how the first stars formed, how matter evolved, and how our galaxy came to be. And perhaps more profoundly, it reminds us that the universe is still filled with mysteries that stretch the limits of what we think we know.